than chemical energy. Hydroelectric plants, you look at hydroelectric, kinetic energy, right? So what we do, when we do produce that work, a part of that energy is always transformed into heat or into thermal energy, okay? This thermal energy is what represents waste. And that's what we're going to look at. If you look at an ideal electrical motor, the efficiency of an ideal electric motor is 80 to 90%. So 80 to 90% of the time, it's actually doing useful work. The remaining 10 to 20% of the time, it's wasted into heat. That energy that's not being used to good use or to good work is wasted into heat. If a motor gets warmer than it should, the efficiency level goes down. And that's what we need to be doing, is to measure and maintain. If you look at motors, the other interesting thing about motors and drives is the fact that motors today consume 65% of the total energy produced. If you look at worldwide, all the energy that's produced, 65% of that energy is consumed by motors alone. That's a big chunk. So maintaining these motors, making sure they're running okay all the time, they don't have downtime, they don't have stops in these motors, is very, very important. So the measurable energy formats. How do we measure this energy? In heat, like I said, in the form of thermal energy, but we also have electrical energy, kilowatt hours, kVAR, apparent reactive powers. Pressure in the form of steam, air, water. These are also quantified energy losses. Mechanical force, friction, misalignments, vibrational forces. These are also energy waste. Okay? So we will look at all of that. So why does measuring energy matter? And this brings me to a famous quotation that one Mr. Lord Kelvin said back in the 1800s, right? Does anybody know? I'm sure all of you know Lord Kelvin, right? Yeah. Right? But he said one famous thing, and what he said was, to measure is to know. If you don't measure something, you cannot improve it, right? So energy waste, saying, okay, yeah, but how do you know? Unless you measure your energy today, you don't know how you can manage that energy waste, okay? So it's very important to measure it. So measurement data will support the decisions and actions you take as a company when it comes to energy savings. Equipment upgrade analysis and ROI, or what we call return of investment. A lot of people think, oh, Fluke thermal camera, $10,000, it's too expensive. Initial cost. Never look at the initial startup cost. Always look at the return, because that's what will give you the money back. Always return on investment. Supply demand, right sizing, optimization for electrical utilities. If I don't have a big electricity pipe, I'm not able to supply enough electricity to my customers, right? If the ventilation system is blowing out more air than it needs for this room, that's wasted energy as well. So oversupply, over-planning, that's also important. Justification for introducing controls and automation. Many hotels and offices today are having building and home automation, right? Maybe some of you have it in your home. Automatic light dimmers, motion sensors, things like cutting off the HVAC when not needed. These are all automation. That's also important. But again, those are expensive. They're not cheap. You know, people change into energy saving bulbs. From a traditional heat bulb to energy saving bulb, these are slightly more expensive to install. So if you need to justify this change to your management, you need to make a measurement to prove what you're doing. Applications for utility incentives. Now, this seminar material has been developed by our colleagues in the US, okay? In the US and Europe, the utility situation is a lot different from what we have here in the Middle East. Good example, Dubai, if you want power, who do you go to? Viva. That's just one choice. Whereas in the US and Europe, you have 5 to 6 companies you can choose from. As a consumer, you have the path to, okay, I'm going to take Mr. A because he's providing me a much more stable power than Mr. B, Mr. P is giving me 10 power cuts a day, not reliable. I have the choice. That makes it more competitive, that makes it more deregulated. So people are curious, want to measure. So then you have things like power factor penalties, right? I'm pretty sure that's not the case here. I don't think you were charged for power factor penalties here. Repairs as well also demand that you measure energy waste as well. So, what's not included in this presentation? So what am I not going to do? We are not troubleshooting. I will not troubleshoot your problems. Predictive maintenance. I'm not going to talk about predictive maintenance because that's a different technology altogether. And I'm pretty sure a lot of you are doing predictive maintenance today. Energy auditing theory. I'm not going to talk about energy auditing theory. That's not why I'm here. Operational cycle time or use assessment. Comprehensive test tool training. This is not a product training seminar. I will definitely not talk about renewable energy. Solar, wind, etc. because that's beyond our scope of study as Fluke. Okay? What we will do is I will help you to quantify energy consumption. How do you know how much is, again, the saying of Lord Kelvin, right? To measure is to know. How do you know? Identify energy waste. Where can you find energy waste? In electrical systems, in buildings, in a production system? What kind of elements you have that you need to measure? If your goal is to lower your energy bill, if that's your intention today, it's saying, okay, I'm spending this much of dirhams in energy every month, I want to reduce that by 10-20%. If that's your goal, you need to review your utility bill, first of all. You need to map your biggest electrical consumers. What are the equipments that are consuming the most amount of load, right? So if you take an example of this hotel is a very good example of a system, right? What's the different loads in this hotel? What kind of loads do I have here? Question to audience. Air conditioning, big consumers. Lighting. Heaters. Yeah, okay. If it gets below freezing, right? Heaters. Elevators, these are all fixed loads, these are also loads. So you've got 3 loads. So identifying your biggest consumers is very important. Use the measurement to determine consumption and waste at each point. Okay, first on an overall system level, and then you sort of drill it down to additional levels as well. Then you can determine what part of that electrical consumption is necessary for your business. What is mission critical? Lighting, I can make with cutting it down a bit here and there, because people are not always in the room. So when the people are not there, I can switch it off. But maybe this HVAC system, or the steam system, or motor, I can't shut it down. I need it for the successive running of the plant. That's critical for me, right? What part is wasteful and can be reduced? So where can I cut corners? So how is energy manifested? If you look at the energy manifestation in the world of power, in the world of electrical, power consumption is a very common form of energy manifestation. Power distortion, right? Power factor going less than 1. This is a common thing now. Nobody has power factor of 1 today, right? It's very, very difficult because in the real world you have a lot of non-linear loads that are causing power factors to always go below efficiency. Overheating, transformation to thermal energy. That overheating is a waste of energy, and that's what you want to measure in the electrical world. Okay? An example here, thermal imaging is a very good indication, or a very good tool that's used to measure and quantify electrical systems. Problems like the loose connection. If I have a loose connection, what happens to that loose connection? What's changing? If you look at the formula for power, I squared R, right? Cable losses, I squared R. What's changing when you have loose connection between 2 contacts? What's changing? Again, I squared R. What is changing? Resistance. Resistance changes, current increases, power increases, and that's a sign of heat, and that's why the thermal camera picks it up. But also if you follow that cable all the way, if you come here, you can see that that particular cable is slightly warmer than the other 2 anyways. And that's telling me, okay, there's probably more load that's flowing in this cable. Okay? Mechanical energy manifestation. Excessive vibration, friction is a sign of energy manifestation. Again, thermal, right? That friction is causing heat, overheating, excessive sound. The motor is making a really bad noise and it's actually telling you, come help me, and you're not listening. Input versus output for air systems. Pressure drops, condensed air, compressed air in HVAC systems. Temperature drops in steam, also in condensed air. Again, a thermal imaging camera is a very good tool to look at steam systems. This is a picture of what we call a steam trap. A steam trap, as the name suggests, is supposed to trap steam. Okay? It's only allowed to send air and water, but it has to trap steam. If this particular steam trap has failed, what's going to happen? You're going to have steam loss. Steam is expensive. Why is it expensive? Because it costs a lot of money to make steam. Right? The fuel used is expensive. You might have to use diesel or electrical energy to make that steam, and if you're wasting that steam away, that's loss as well. Okay? So this is pretty much how you can how energy waste is manifested. So how do we quantify? With a collection of tools. In Fluke for today, we will be focusing on a very select few products that are really useful in energy consumption, because these products will help you to identify and quantify where that waste is happening. Okay, so again, depending on your application, we'll talk about that. So in the electrical world, kilowatt hours, energy consumption, to measure harmonics, because harmonics is manifestation of heat as well. Unbalance, power factor, peak demand is something that is also measured with power quality. Vibration, PSI stands for pounds per square inch. Pressure differences, heat, and of course the delta T. The delta T is the difference in temperature, is what you also want to measure. So how much can you save? Now, obviously before we wrote this material down, we did a lot of VOC. And that is something that Fluke is good at. VOC stands for voice of the customer. Okay? A lot of our products that you see, we call it innovation, but these are really based on you, built by Fluke. And in the video you saw that the guy was saying, you know, these are tools that are perfect for engineers and electricians because they are made by engineers and electricians. And that's the Fluke difference. We have been making tools for 65 years. We know exactly what industrial professionals need from a tool. And that's how we make them very good. So we went to a lot of companies. We spoke to a lot of different organizations that are currently doing energy waste management. And we asked them, you know, how are you doing it? What are the different tools that you're using, etc. So in general, we have found out that facility management or facility energy audits can reduce utility expenses by 25% within the first year. And that's an average. We find that's a very common number that we get, 25%. Depends on size and age, of course, of the type of facility and the scope of energy logging. Okay, so it's a big facility or a small little office space or a big data center. Facilities with good proactive maintenance programs. If you already have an existing predictive maintenance program, you're halfway there because you're already doing a good job in measuring and predicting condition of equipment. You can save about 10 to 20% of energy in the first year. In facilities where maintenance still is fighting a lot of fires, we call it reactive maintenance, right? Which is just reacting to the problem that happens. You have no condition-based maintenance program at all. You can definitely look at 30% savings in the first year alone. So biggest savings opportunities. Where do I find the top dollars? Where can I cut down the most amount of cost? Looking at an industrial facility, power coming in, transformer side, not the biggest. This is what we call the smallest of opportunities. The biggest opportunities are in your lighting, compressed air, steam systems, so motors and stuff. HVAC motors and drives, and the least amount of places where you can expect energy, or we call it a small opportunity, right? So this is a small opportunity, the building envelope. Also electrical utility, IT computers is a small opportunity compared to the entire system, whereas a medium opportunity is HVAC, motors and drives, and the biggest opportunity is, of course, in lighting, compressed air, and steam systems, etc. So where does the waste happen? So again, this is a hospital in downtown Chicago where we did do a sort of a VOC. This customer is managing this entire hospital, and he did it, or he is successfully doing his energy with 3 tools. He has three basic tools. He's got a couple of DMMs, he has 1 power logger, and 1 thermal imaging camera. That's all he has, right? So if you look at it, it's not a lot of tools. 3 simple tools, but effective in what it's doing. So where does this waste happen? We will focus, in this seminar, 3 building systems, okay? All of you might be from a different part of this building system, but the objective is to show you what you can do, how you can do it, and how you can quantify it. Electrical subsystem, this is the first. So if you look at a 3-phase distribution, power coming in, branching out into the different loads, electrical subsystem or the utility building. We'll spend probably a lot more time on this one, a bit more complicated to understand what is the energy waste here. Then we will move into production process system. We will talk about motors, mechanical loads, but also compressed air, steam traps, and so forth. And then finally, we will look at the building infrastructure. So HVAC, building envelope, and lighting as well. We'll look at 3 different sections of that. Okay? So, in the electrical subsystem, what are the waste points that I have? So where do I measure? It's always a question that we have as maintenance engineers. Where do I start? Where do I troubleshoot? And the way we do it is, I like explaining it in this way. Think of ourselves as the CID or the police, right? If somebody calls up, well, let's say Dubai police, and says, we've seen a murder or an accident at so-and-so road or so-and-so shopping mall. What does the police do then? Do they just take the details down on the phone? Okay, how is he lying? Is he flat? Is he wearing do you see a knife there? Do you see a weapon? What do the police do? What's the next thing that they do? Exactly, you go to the site, right? You go to the scene of the crime, because that's where you get your clues, your evidence. And as maintenance engineers, that's what we're doing. If you have a problem with the motor, if the motor is humming, making a lot of noise, you go to the motor. You don't go to the VFD first. You go to the motor and start troubleshooting. If you look at the main service entrance, where the power is coming in, you definitely want to measure for waste here, because measuring for waste here will give you the complete picture, the overall wastage. But it doesn't tell you which particular component is causing that waste. For that, you have to branch down. And that's how you do it. You go to the first load, which is looking at the motor sides. Second one, which is lightings, computers, and so forth. And you might have another one also for motors. Here you have a capacitor bank. Again, what does that capacitor bank do? Reactive power feeds it back in to get your power factor a little bit up, right? A lot of companies or installations might not have capacitor banks because they feel that, okay, my power factor is good. So you need to measure for waste, and you measure it at each load side. And that's how you do it. So, identifying waste from the utility bill. I wanted to remove this slide, but I decided to show it anyway. This is an example of how the utility is billing in the US, for instance, okay? Key questions: how much does the electricity cost? Does everybody know how much you are paying per kilowatt hour here to Viva? Show of hands. At least for your homes. You get a bill, right? Yeah. But do you actually look at the charge? Be honest, I don't. I never did. Right? We don't. We just don't look at it. So you need to know how much that costs. Are you being penalized? right? Are you penalized? Well, I have in some cases when I use too much electricity. I know in my old house I used to always have the AC on. Consumption was more, so what they did was they would put an extra surplus charge, right? If consumption crossed a certain amount of kilowatt hours, there you go. I'm going to slap you with an extra few dirhams of charge. How much are you consuming? What is your consumption today? As a consumer, as a company, you need to ask yourself these questions, without which you don't know what to improve. Again, Lord Kelvin, if you haven't measured something, you cannot improve it. So things like maximum demand charges, fixed demand charges. Maximum demand, or what we call peak demand, is when you take energy measurements every 15 minutes, it's the maximum of these averaging 15 minutes. That means the peak demand tells the utility company how big the electricity pipe should be, because that's the maximum I can expect from the consumer. Power factor rate. We are not charged here for power factor. I think we're lucky, but I know that in Saudi Arabia, they are. Especially for industrial customers, I think they do charge penalties if you go less than 0.94 or 95. I'm not sure what it is, but they are charging power factor penalties. So understand your energy bill. If your goal is to reduce your energy bill, you definitely want to know what your energy bill is telling you. So how do they measure energy consumption? How does utility measure? Now, we would measure with tools like that. Of course, utility also does the same thing. They will measure the energy consumption in kilowatt hours. Okay, it's an expression of accumulation of power over time. So that power is just kilowatts over the hours. And that consumption the consumption charges are broken down. This is again in the US, not applicable here, but just to show you what they do. Active power, which is delivered by the utility. That's the power that's coming to you from the utility. They charge you for that. They charge you for variances due to the power factor. If you've got low power factor, we're going to charge you X amount of money per every reduction, and they will charge you due to market demand. If you're, let's say, part of a group of 5 companies that's drawing power from one, let's say, substation, if you are using the maximum amount of the power between the 5, you will be slapped with a higher bill. So there is variances there as well due to market demand. And this is how utilities measure that energy consumption. So then, of course, we need to know what is electrical energy. Okay, power, which is basically energy required to do actual work. That's power. It's always measured in kilowatts. It's the rate at which AC energy is expended, such as running a motor. That's the power of the motor. And then you have something called demand, or kVA, which is apparent power, which we call system power. Okay? So if you look at this empty glass, right? I always like to explain it this way. Empty glass. This is apparent power. This is what the system is designed to hold. I pour the water, right? The water starts coming out. That's reactive. That's the waste, because the system cannot hold it, right? And that's what you want to measure. And then everything else, like power factor, harmonics and imbalance, these are all waste. Power factor is not a waste, but it's a measure of waste, of course. But harmonics and imbalance is a very clear example of inefficient power usage, and you want to be able to measure that as well. Power factor, when a circuit operates at 100% efficiency, demand is equal to supply. Power. And if it's less than the demand, the difference is what we call power factor. So the true power divided by the apparent power. That's the measure of power factor. Okay? Power factor below 0.95 is inefficient. In some cases, in some applications, a less than 0.95 power factor might be accepted. It's fine. Again, it depends on the application, it depends on the customer. But typically, less than 95% means you are inefficient. All right? So how does it work? If you look at the rate of energy flow, this rate of energy flow in a system is dependent on the load, purely dependent on the load. Is the load resistive? Is the load reactive? If you have a purely resistive load, you get such a waveform where the voltage and current reverses polarity at exactly the same time, right? They are in phase. They are syncing in phase with each other. The product of voltage and current is positive, and you always have a net transfer of energy to the load. Pure transfer, 100% power factor of 1, unity power factor, and you have real power. But if the load is purely reactive, okay, now you have voltage and current being out of phase. They might be leading, they might be lagging, depending again on the load, the reactive load that you have. And the product of voltage and current is negative. There's wastage flowing back. And that net transfer of energy to the load is 0. What flows is only reactive energy. And reactive energy is not doing anything for me. It's wasted. It's useless for me. I cannot make any use of reactive energy. So most loads will carry a combination of resistance, inductance, and capacitive loads, creating both real and reactive power. Okay? Gone are the days when we had purely resistive loads. We did have it 20, 30 years ago. We had purely inductive and resistive loads. But today, it's a mix. We call it non-linear load. It's a mix of resistive, capacitive, and inductive loads. So, energy logging, why and where? You need to map your consumption because you need to know exactly how you are consuming that energy, what's causing energy peaks, etc. And you compare this measurement with your utility meter. The first main sign of an energy waste is your energy bill. You look at your bill and then say, wow. Or your company finance guys will look at the bill and say, hey, how come we're spending more money this month than last month? While the production is the same, output's the same, suddenly the energy's gone up, right? What am I doing wrong? They will look at that. So compare, you need to make a measurement and verify before you point fingers at the utility. Because a lot of times, 80% of the time, consumers like to blame utility for energy problems and power problems. But 80% of the time, the utility is not at fault. The utility is at fault 20% of the time. 80% of the time, you as a consumer, you are the most cause for all these energy problems. So measure and you cross-compare. You check with your utility bill just to make sure, okay, fair enough, they have charged me for what I'm using, so I do have a problem. I need to look at what it is. Evaluate peak demand and any power factor changes. Monitor your power factor changes. See how it's going up and down. Where you log the power at the main and secondary panels and at major loads. So I talked about the main service entrance, and then you branch down into the individual loads. You record for energy, energy over time, and power factor. 3 key measurements you have to make. You identify any peak usage times. So is there a particular time of day where my usage is the most highest? Maybe from 8 to 5, because everybody's there and working, right? 8 to 5 is going to have peak demand. Determine if that usage can be adjusted. So between 8 and 5, can I adjust it somehow? Maybe I will have 6 people come and do the job instead of 10. So they're not doing all that. Maybe I can make it a more leaner organization. So think about these changes. How do I do these changes? Tool for energy logging. So let's look at a very simple, okay? And I'm not talking about a very complicated tool. It's a very simple tool for energy logging. That's the Fluke 1735 power logger. It's a very good power logger because it's a 30-day power and energy logger. Simple if you just want to do load studies, if you just want to